recorded now?
We are all recording.
We are recording.
So I'm going to bring up my Word document. Energy storage system as an optional standby. All right. We are back.
Welcome to the latest installment of the CQD Spotlight, Mr. Dimitrovich.
CQD, Mr. Kyle, I think I am ready for another hard question.
Hard question.
That we will dance around until we get a good answer.
All right. Well, maybe let's start with some intros. Hey, so once again, you're...
I just happen to be Thomas Dimitrovich with Eaton, Director of Codes and Standards.
And Kyle Krieger, Executive Director of Codes and Standards for NECA. Welcome again to another edition of the CQD Spotlight, Code Question of the Day Spotlight. We're going to talk a little bit about energy storage systems today.
I like energy storage systems because we have 1, 2, 3 batteries running and cameras, plus we have the batteries in our computers. You know, energy storage, I can remember when I entered the industry. It was in 1990 I graduated from college. And when I went into what in our world, energy storage was in power plants, in big commercial or industrial buildings, right? Schriever Air Force Base out in Colorado had a huge energy storage system, but you never saw it in dwelling units. You never saw it and now we're seeing them in more and more and more in dwelling units and light commercial applications with electric vehicles. And you've got wind, you've got solar. And they think about if solar, they get the power from the sun, but the sun's not up all the time. So then they take that energy, any excess, they put it into a system, a battery of some sort. And then when they need it, they're going to tap the battery to get the power. And this one here, this question, they want to use it for, what is it for us? The Article 7.
So yeah, this one, it's unique, right? It's a little bit unique because and maybe it's not unique. Maybe it's just the terminology in the NEC needs to evolve, right? When we get into it, we talk about this a little bit. So this question came in, and I think we actually ran it for February, so it may not even be published yet. So a little might be.
Oh, really? This is hot off the presses.
Hot off the presses. So this one question asks: can a 5 kilowatt-hour energy storage system (ESS) with a max output of 20.83 amps supply a 200 amp service of a dwelling unit when the normal power source is lost? The conductors from the ESS are 10 gauge THN copper conductors. So I guess in my mind, there's a lot of things at play here, right? So we're talking about it could be any number of manufacturers' energy storage system. It's essentially a battery, right?
Right.
So it's collecting energy from somewhere.
Sure.
In energy storage, you could essentially use the battery of your electric vehicle.
That is an energy storage system on wheels.
On wheels, there you go.
Yep.
But in my mind, when I hear a question like this, I think, we're not talking standalone system because they clearly reference when the normal power isn't working. So there's an interconnected element here.
Yep.
So it's likely an energy storage from a PV or something like that, I would imagine. So, or maybe it's just like a Tesla wall or something that just has batteries.
Yeah. So you have to have the energy storage system itself, like you said, it could be a Tesla, it could be whatever the battery is. But then what is putting energy into it?
Yeah.
Can be a myriad of things.
Yeah, it could be just charging off the normal power system.
That's exactly right.
Right.
Yeah.
So that's the first step here is I guess you really kind of have to understand the use of it, right? And if it's to provide power when the normal system isn't operating, to me, that's an optional standby system. Now, our mind typically goes to when we think of a 701 or 72 or 700 system.
Yep.
We think of like a prime mover type source, like a generator.
Sure.
But to me, it really is more than that. Like, I don't think they're mutually exclusive. I don't think it optional is just generator. I think it's any alternate source that is.
Oh, I agree with you. And all we do know in a 702 system, we know based upon the definition and the scope of 702 that the alternate source just can't be a utility.
Right.
So
Right.
we know it's got to be. It says, because I ran into this. You got to look at the definition of, was it optional standby, right? Outputs.
And we're not, and for those you listening, we're not dancing around the question, but I think that this determining the use of this system is going to play into how the question is answered.
Exactly.
So I think that's the first step in this problem, is identifying what this system is, and then going from there.
And then, so optional standby system is defined in the code as those systems intended to supply power to public or private facilities or property where life safety does not depend on the performance of the system. These systems are intended to supply on-site generated or stored power to selected loads, either automatically or manually. So we know that an optional standby system has to be on-site, either a generator or stored power. And this question is talking energy storage systems.
Yeah, I mean a UPS, right? That's an additional optional standby, or it could be a legally required or emergency too, depending on it. But
There are provisions, and I think over the last, I know in the 2026 they're still tweaking, and I think the last code cycle, I'm not sure about 2020, but we're starting to, there's this effort to recognize energy storage systems as a source of power for things like Article 700, even in Article 517. They've got this drive to say it's not just about a generator. If it's a reliable source, and whatever that is.
And I think we're going to start seeing that same trend in NFPA 110 and 111 as well.
Absolutely. So here was a last cycle. I'm on 110, 111, and we had this discussion. What somebody wanted to say was that you can use they call that when you have different power sources all networked together.
Microgrid?
Microgrid. They said a microgrid can be an alternate source. But my issue with that was a microgrid doesn't tell you what it is a microgrid of. Okay, if I had a microgrid made of all photovoltaics, I would not say, oh no, that microgrid would not be able to act as a backup power, because only if you lose power during the day, and if you have enough power, there's
definitely a need for an energy storage method that has to be part of that microgrid. And we're starting to see that trend in healthcare facilities, right? And usually there's a generator that's part of that microgrid, but there's also energy storage that offsets and augments the overall need for a massive generator if you have some alternate storage systems that can then help with that.
Sometimes the best solution is divide and conquer.
Divide and conquer, right? So back to the question. So when I look at this, the question as it's posed, it's really about, we have an energy storage system with a 20 amp output on it.
Yeah,
and
20.83.
And they're looking to find out if they can, do they have to do something
to implement
to implement it with, or can they just feed the entire 200 amp service of this dwelling? And if you look in Article 702, there's some guidance there, right? There's some guidance there for optional systems. And it, with anything in the NEC, you can almost be assured that it's going to say, hey, if you have to be rated for what you're supplying, or the branch circuit, the conductors have to be rated for the supply and things like that.
Yep.
So there's language in 706 for the output conductor sizing and things of that nature.
Wait, 706.
706 is the energy storage system.
Okay, yeah. Okay, yeah. Perfect.
But going back to, do we have to put a larger energy storage system on for this optional system for a 200 amp dwelling? It comes down to how that's controlled, right? If we have manual connection, then as an optional standby system, the capacity of that optional standby system just has to be rated for the equipment it's going to supply.
Yeah, in a manual, you can turn off the loads
Right.
because you're there. It's a manual.
Yeah. If we're going to utilize the energy storage connected using a manual transfer method, it's only going to supply at 20 amps. You're likely only going to be able to supply some general lighting and maybe a well pump or a sump pump, or something like
Sure.
that. But it certainly is not going to be enough for the entire house, more than likely.
Right. So you're going to have to turn something off.
Right.
Yep.
If we connect that ESS with an automatic transfer, now we've got a little more of a task at hand, because this 702 tells us 702.4, I think, is the actual section, says that if we're going to have automatic connection, we have to size it for the loads that are going to be automatically connected or provide some type of load shedding capabilities, right?
That's right.
Same concept. You can't just tie it into a building that's normally drawing. Even just because it's got a 200 amp service, we know that it's not, a dwelling unit isn't going to be drawing 200 amps, but maybe it's 80 amps or 90 amps, depending on what type of loads.
In this case, all it has to do is be more than 20.83.
And yeah, right, exactly.
Yeah.
So it really comes down to the equipment you're connecting and the method you're using to connect it, right?
Right.
We were talking about, is that going to be permitted or not? So the answer, I guess the short answer is yes, it would be permitted. Now we got to whittle down, how are you going to connect it, manual or automatic? And then we have to be very selective about the loads we're applying it to.
That's right.
It can't just be a general, we're going to feed the whole house and cross our fingers, hope for the best, right?
Right.
So let's see, what are some other things?
You've got to think about what is the system that you're going into. But there was another thing I know it. Okay, manual. This was posed to me. This was posed to me. What if your house is in DC. I'm in California. And I look and I get a weather notice that power went out of my house. And I go like this on my phone and I go, I'm going to turn on my generator.
So what's manual, what's automatic?
Yes. And manual.
That line is getting blurrier and blurrier by the day, right? When you really think about it, because is there anything, even if you look at the loads in your house, right? What's load shedding, right? Is it automatic load shedding capabilities?
Yeah.
I could turn off half of the lights in my house with some type of AI device right now if I wanted to.
That's exactly right. Yeah, drive everybody crazy.
So that line is definitely getting blurred.
Yeah.
So
I can be remote. No, the line is getting blurred, but I could, depending upon the app, I might be able to open up my phone and say, oh, I know I have this much load. And to your point, I might be able to say, I'm going to turn this off, this off, this off. Now I know, okay, I'm ready to go, and I can turn and do the transfer. But there's nothing in the code that addresses that. We assume today that when I say manual transfer, that I have somebody, everybody pictures this in their mind, somebody's standing in front of that panel board and
click.
But manual transfer just is that I am making the motion to do that.
Human intervention.
It's human intervention. That's exactly right. Yeah, exactly right. So
now that's not a definition, but that's what I would.
You know what? This is Tom and Kyle's definition.
Tom, yeah, we don't want anybody going in the comments saying manual intervention. Where'd you pull that stuff from?
Oh yeah, we're going to create our own defined terms.
Defined terms.
Yeah, this will be CQD. Tom and Kyle's
defined
definition. So, but this one I think is relatively pretty straightforward.
Yeah, I think it's more of that because we have an article for energy storage, right? That as soon as you call it an energy storage system, it's like we're this artificial confine of
Yeah.
Article 706, and if 706 doesn't address it, now what do we do?
Yep.
And I think that this is not the only time this is going to come. This comes up with standalone systems all the time, right?
Yeah.
When you're into 710, those two systems are not mutually exclusive.
No.
Something that can be disconnected and taken off of the interaction with the utility, now it becomes a standalone system,
That's
but
right.
it also could be used as an optional
Oh my
system.
gosh, that is, I've had that discussion with people, and it seems like sometimes you just go around in circles because you'll have someone say, "Well, wait a second, if I have a system that works in parallel, but the moment I lose a utility, it shuts off, and now it supplies loads on." So is that a 710?
standalone
Is it a standalone system?
It is as soon as it no longer. As soon as it meets the definition of the standalone system.
Yeah, and it flies on the fly. And then now we have, so then we had, I think, it wasn't last cycle, but we had the introduction of Oracle 750 for energy management systems. Okay, that entire that discussion there took its own. I would say that's taken its own journey because we, when I first started with Eden back in '96. I was on a help desk, and we did a lot of work with large customers who were using our energy management system. Back then, we had Wonderware, Iconics, we had our own software, and we would communicate with all of our trip units. We had meters, and we would help a customer know, for example, let's say that you make cameras, right? If you had our system, you would be able to say, here's how much energy it takes to make a lens. Here's how much energy it takes to make the body. And then you could put the departments, this is what they actually did. They put the departments, they gave them a budget for energy. And they said, if you figure out how to save energy, you hit a peak demand last year, you got hit big, right? If you don't hit that peak demand this year, that's that much more money in your budget that you can go do something else with. So they made it that type of an approach, but it had nothing to do with safety. Now, we put the Article 702, put the requirement in for the load shedding requirement. It was a few cycles ago. And I remember I remember doing the educational programs, and there was a lot of discussion. And we said that if you had an automatic transfer switch, you needed to manage the loads, right? And that was driven off of the hurricanes that came in through Florida. People thought that their generators were starting up and working, but they were overloaded. So they put this requirement in, but there was, and you could argue it's not a life safety. I guess it's
An
not
optional
life safety.
system, no, it's
No.
not.
But if you're using like an energy
But
management,
on that topic though, there's very similar requirements in 700 for for emergency systems and 701 for legally required standby systems
right?
from a capacity standpoint. Now, automatic connection is mandatory with those,
Sure.
but the system's got to either be sized. Well, it's got to be sized for all of the emergency loads or legally
Yeah.
required standby loads.
And then if you have non-emergency or non-essential, then you have to
Then load
transfer
shed.
switches and load shedders,
Yeah.
right? So my point being is we were using those systems to perform safety-related functions, but we were still calling them energy management systems. Now we've expanded that with interconnected systems, sizing feeders, sizing services, sizing a panel board based upon a set point in an energy management system. So in the 2023, they started to introduce the power control system, creating a new standard for it. So now we've got this separation. What we always used to just lump into, this is all energy management because you're shedding loads and you're controlling your loads and you're right sizing the equipment based upon the supply or whatever. Now we're starting to say, hey, this is a safety function. And we've got people saying we need a different standard because to size your service or a feeder or a panel board or a switchboard off of a set point, we got to make sure that it's it's going to be the right set point, and if it's getting that set point from the cloud, just because the internet went down, its brain didn't go south.
Right.
So there's this world of energy management and automatic load shedding and doing things related to your power system to manage and match the source with the equipment is getting a lot of focus.
Yeah, and I think that from a National Electrical Code standpoint, I think that we're going to have to evaluate the terminology that we use. From right now, it's a service is supply from utility coming into the building, and that's how our traditional electrical systems work.
Yeah.
Everything else is an alternate power source, but we might not be in that world anymore. We might have to redefine what a service is and maybe go away from the term altogether, services, and just call them power sources. Go away from the term utility services and just say everything's just a power source.
Oh my gosh.
Because
You're
really,
right.
it just makes it that much more messy.
I'll give you a good example. I've been doing the homework of like why was all around services from the 20s up until today. Our world has changed considerably. In the 20s, like in 23, I think it's the 23 code, if I'm not mistaken. If you think about what was going on in the 1920s, most of our homes still had gas lamps, right? So, and very limited electric power usage. And then you have today where we're just so dynamic and diverse with the energy that you're using. So if you take the utility transformer, okay? You have a transformer that might be outside. On the primary, you have primary overcurrent protection. Probably got a fuse up there, up on a pole or something. You hit the transformer and then you come into a panel board in the house. We call that the service, right? But if I took that little one-line diagram and I put names, I say, okay, on the top is the fuse, and this is a utility fuse. This is a utility transformer. This is a secondary breaker and a panel board, which is your service. Take all of that off and just draw the picture of a feeder transformer. You have a main breaker, you have a breaker feeder feeding or a fuse feeding the transformer. You have a panel board on the secondary with a breaker, but now it's not a service. But it's the same situation.
And same rules, same concerns, same everything.
Absolutely, same hazards. You haven't changed. The electrons don't know that this is
Right.
This is now a service.
This isn't being generated by a publicly owned utility or
Right.
Yeah.
Yeah, and then we made some changes in Article 215. I think it's 215.15. I'm gonna go out on the limb while I check. But what we did in 215 was we recognized that 215.15 barriers. So we said, look, if you have the first piece of equipment on the secondary of a transformer, any transformer, you need to barrier those line side lugs for that termination, for the same reasons that you have the barriers in 230.
Yeah.
So I think it was that when that change went in, as we were debating it, you see a change go in, and then we do sessions like this where we're talking about the requirements. And I drew the one-line diagram, and I thought, man, if I would call that a utility transformer, if I called that main overcurrent device a utility fuse, it'd be no different than a service. So I agree with you to an extent that we really need to refocus, look at the defined terms, because what you're talking about is what is a transformer secondary conductors. We just came up with a new term in the 2020s. We're going to put this in the 2026 code. But we said that conductor that goes from the lugs of the transformer to the first overcurrent device is not defined. Right? You could argue, you can say, well, that's transformer secondary conductor. Okay, it is. But if I integrate like a secondary breaker with that transformer, now my transformer, what is the transformer secondary conductor, right?
These are conductors from the transformer to the overcurrent protection.
Or from
then from the overcurrent protection to the load is that feeder.
It meets the definition of a feeder, but it also meets the definition of a transformer secondary conductor. So we're adding that clarity. But and then what do we call the conductor from the generator terminal to the first breaker? We don't have a name. Unless you want to call it a power source output conductor.
Yeah.
Good. There's all these conductors that don't have a protection at their source. And the PV has been facing it, and they've been trying to deal with it, right? They created some new terms,
Yeah.
and they've been trying to define these different conductors because in some cases they're not a feeder because they don't have overcurrent protection at the source. You think about a photovoltaic panel. You come off the photovoltaic panel and you daisy chain all of those. There's no overcurrent protection at its source. And then you go to an overcurrent device. Well, what do you call that conductor? They call them power source output conductors. How do I protect it? I agree that there is a lot of opportunity. And then you have to ask, why do I call it a utility? Why do I call it a service? Why do I associate it with a utility? Why do I have to do that? The only reason would be I can't shut it off. I got to call somebody to shut it off. If it's a PV panel, I can't shut it off.
Right.
I got to call the big guy.
Yeah. He doesn't take my calls so much any longer.
Well, you got to be a good boy, Takao. Come on. But no, I mean I agree with you. There's an opportunity to really focus on that.
So what do we got for key takeaways here, Tom?
Well, yeah.
Back to the energy storage
question
system, and our submitter here. So I would say yes, you can use it as an energy storage system.
Yes.
To provide backup power. It could even the 5 kilowatt hour 20 amp output one in the example you could use on a 200 amp service, but you got some rules that you got to follow and some loading issues that you got to address.
If it's a manual transfer, there's no additional rules.
Yeah,
if
just make sure you connect when you're transferring. You're only transferring loads that ESS can handle.
And if it's an automatic, you need some sort of energy management to shed all of your loads automatically while you're not there.
Makes sense to me.
And then I think it would be hard if it was an Oracle 700.
Yeah, once you get into the emergency or legally required standby, there's
well, let's put it this way. Now I would say not the 200 amp panel board, but if you had an energy storage system on a fire alarm or emergency light,
well, they do.
They do.
Technically,
Exactly.
they do, right?
And you can get away with that.
Yeah.
In an Oracle 700 system, you don't need a generator if you have, what do they call that, unit powered?
Unit powered,
Yeah.
Unit equipment, battery backup, exit signs, egress lights.
That's all permitted.
Fire alarm panels.
As long as whatever your load you're supplying is going to be able to be powered for the duration that they are required to be powered. So you may not be able to do a 200 amp panel board with it, but you could use it for unit equipment.
You just popped in another good topic that we could discuss real quick here.
Yeah.
So, remote heads, right? We install remote emergency lighting heads. So we have these requirements for emergency lighting in 700.
Okay.
It says if I have an exit discharge by the egress path that leads folks to the exterior of the building,
right,
there has to be an emergency light outside that illuminates the discharge area.
Sure.
Typical installation of that is I will have a exit sign on the interior of that exit stairwell.
Right.
And then on the outside, there's a remote head that shares the battery with the exit sign on the inside.
Really? Okay.
Yes. So now that battery
has to supply both loads.
Both loads, right?
Yep.
So the circuit coming from the battery to the remote head.
Yep.
Is that an emergency circuit?
Well, I would say yeah.
Absolutely.
Yeah.
So if I, for example, am wiring a multifamily dwelling unit that meets the criteria in 334 where it's a type 3, 4, or 5 construction, I can run an M cable.
Sure.
For every segment of wiring in that building.
Uh-huh.
But where I have the egress exit points, if I'm using the remote head fed from the battery and the interior exit sign battery, that one segment from that exit sign to the remote head is going to have to be in a wiring method approved by Article
that's
700.
Right.
So every other piece of that building could have an M cable, except for that whip from the exit sign battery to the remote head on the exterior.
Wow.
Throw a comment if you've ever gotten gigged by that. If your inspector's ever been sharp enough to catch that one.
I tell you what, if you have, it's amazing when you have a really good inspector, the stuff that they can find. Oh my goodness. And then installer documentation include a load analysis, breaker coordination. I don't know about, well, it depends on the functionality. But you definitely need to, if you're going to have a transfer switch, you should probably do a load analysis to show the inspector that the load that you're supplying, especially this one with 20 amps.
Yeah.
If that my radar would be going off if I was the electrical inspector looking at that. But even without an inspector, even if you were going to do something like that, just as a contractor or a designer, it's like a no-brainer. You better do your load calculation. Don't just throw it on there.
So if you had 20 amps available to supply anything optionally in your house, Tom, when the power goes out, what loads would you make sure operate? And
The coffee pot.
okay, that's it. Pretty much that.
Yeah, it is a big coffee pot.
That's about 12 amps.
Yeah,
Done.
Yeah, probably. I don't know, but the coffee pot's important because everything else. I mean, I've got a gas fireplace, so that's going to heat up, and I only got 20 amps, so you got to make a good cup of coffee.
Yeah, that's an important one.
Yeah, can I have two loads? I mean, if I'm not making coffee, I could put I have one of those.
You might have to go down and shut off the breaker and turn on.
But I can have one plug. I'll just unplug the coffee pot and I'll plug in my air fryer. I can do a lot with an air fryer.
Now I'm curious. So see, and coffee pot. I'll run to Starbucks and get some coffee.
Yeah.
Me, it's gonna be like general lighting, television,
Candles.
maybe
The router, your web
the Wi-Fi, the
Wi-Fi.
router,
Yeah, I thought about that.
Hey, we can't post podcasts without. You can't do Tommy live,
Tommy Short Pants Live.
Tommy Short Pants live without any without internet service.
That's exactly right. Gotta have your internet service. And if I lived where I used to live, I used to live out in the country. I had a well, and I had a septic system.
Oh, those would be definitely.
Oh my! I put a backup automatic transfer switch in a power system in because I wanted to be able to have those two functionality.
They make some pumps now that come with energy storage for optional power supply.
No kidding.
Right in. Battery backup, right direct to the sump pump.
Really?
Yeah. I've seen them. There you go.
There you go. Well, that's a sump pump, though. That's not a well water.
Yeah, but that can be pretty critical in a power outage situation, especially if it's storm related, right?
Yeah, no, that's a good point. There's a lot of reasons why you need a backup power system, and I tell you what, honestly, I have a gas stove and I have a gas fireplace. I tell Bobby Joe, I say, if we ever have, which we did, we had an outage for a few days. We were able to cook. I was able to heat the house. Two critical functions.
Check and check.
And we had city water, so I can get my water. We can always boil, make soup. You can take your shoes and just boil those shoes. And the 3 day gone good.
See, I think the internet has moved to the top of my list. It may be a little less now that my daughters are off to college, but when I had 3 teenagers in the house and 2 of them teenage daughters at the same time,
yeah.
If the internet would have been out for any extended period of time, it would have been a catastrophe.
Oh wow!
I mean, I think internet, water, sewer, internet, sewer, water are the 3.
There are parents. And I've seen it. That's their babysitter. You throw an iPad up, throw on their favorite cartoon. You'll entertain those kids for years.
Yeah.
Is that what your wife does with you?
Yes. Give me an iPad, I'm good.
Throw a video game up and Kyle's
a video game. Yeah, exactly.
Beautiful. So did we beat this one up good enough?
I think we did. I think we beat this one up fairly well. And if not, let us know.
Please don't forget, you can go out to Code Question of the Day, put a comment or a question in. Also, to these videos, you'll be able to comment on the video. Cal and I will be religiously watching these.
Yeah, and who knows? Maybe we'll pull some of the questions that we get in the comment, and we'll put them in the Code Question of the Day daily.
We can have that discussion.
forum, yeah.
And then we plan on doing some live sessions where we're going to take some questions live. Right now, we're recording these. We haven't told anybody yet.
Yeah,
We're recording these at NECA headquarters in Washington, D.C., just down from the White House. In fact, I think the president was supposed to come over.
yeah.
And he hasn't called, so maybe
Not
that
yet.
was him trying. I think I hung up on him
You
twice.
did hang up on him twice.
Yeah, but that's okay.
So now we're not going to have him.
Yeah.
You can
Donnie
see
will
the
be back.
Washington Monument. You can't see the White House, but coming from you live at 1201 Pennsylvania Avenue, baby.
Absolutely. 1201 Pennsylvania Avenue. Check your calendars.
Eka HQ.
Awesome. All right. We're going to tune up for the next one. Thanks for joining me.